morning, good afternoon, everybody. Welcome in from around the world. My name is Jesse, and I'm your virtual adventure guide here with Exploring by the Seat of Your Pants. Now, welcome to the broadcast. We are all about bringing conservation, adventure, and science into classrooms like yours around the world every single day. And it has been a particular treat for me, having had the opportunity to join in on this incredible series live from Antarctica over the last month and a bit. Now, I want to say thank you for your patience to all our live classes and YouTube groups for having a little bit of tech problems today. Sometimes when you're broadcasting from the edge of the earth, it just does that. But I really appreciate you guys sticking around as we get to continue this awesome series. Now, before I turn it over to the outreach team to explain a little bit more about what it's all about, and we go live with Arunima in McMurdo Station to talk about the introduction to space weather today, I wanted to note that all these programs are on our YouTube channel. So if you want to hear from Jackson, Ian, Yingfei, just amazing trio of presentations that we've done in the McMurdo series over the last month and a bit, you can check out Live at McMurdo as a playlist on our YouTube channel. They're all there. I really encourage you to check them out. There's a lot of exciting insights and stories. Now, without further ado, with the hopes that the tech lasts us, let's all cross our fingers together. I'm going to turn it over to Daniela Pennycook. She is going to tell us a little bit about how this series came together and the amazing work that series does to showcase such an amazing place on this planet. So Daniela, I'm going to turn it to you. Thank you so much for joining us today, and welcome to the broadcast.
Hi, Jesse. Thank you so much for having me. It's so nice to see all of you and be here with all of you today for our fourth and final webinar in this series. I'm Daniela Pennycook. I'm here from Ceres Education and Outreach. Ceres is the Cooperative Institute for Research in Environmental Science. We are the NOAA partner here in Boulder, Colorado, and in the Education and Outreach group, what we do is communicate the science that is coming out of this research institute to the public through webinars and curriculum and lessons and teacher workshops, both virtual and in person. So we're really excited to connect with you all today and connect with Arunima all the way down from McMurdo, Antarctica. Thanks, Arunima, for joining us today. I'm excited to hear about space weather.
Fantastic. We've got the slide deck up now. Again, I know we've got sort of this relay system with our slides today. So Daniela, I'm
Hey, hi, welcome everybody to Space Weather.
Yep, we can hear you. You're good to go.
Perfect. Daniela, could you go to the next page, please? Hi, so this is me. My name is Arunima, and I'm a third-year PhD student in CU Boulder Aerospace Department. And I'll be leading the LiDAR research for the next season at McMurdo. And this is my first season in Antarctica. I have a master's and an undergrad degree in electronics and astrodynamics and satellite navigation. And I worked on a few satellite missions, SRM-SAT-2, WaferSat, and Maxwell. So yeah, let's get started with introduction to what is space weather. So before we even get to that, let's see where we are geographically. So South Pole is literally right in the center right here, and McMurdo would be right at the edge at the Ross shelf right here on the ice shelf, basically. So we're a little off South Pole, but not that far. Next slide, please. Next slide, please.
Daniela, I think we're actually good to go back to the last one. I think she's just so delayed that it's, yeah. There we go.
All right, perfect. So, could you click on the video to play it? Not sure. So what do we do down here at McMurdo? So we are a group of students and professors who shoot like 3 laser beams into the polar sky to sense the atmosphere above us, going from about 20 kilometers to all the way up to like 140, 150, even 200 kilometers. And we measure temperature, wind, metal densities, and what changes occurred during the time that we take these observations. And apart from that, we also measure and detect polar mesospheric clouds and polar stratospheric clouds. Yeah, if you could go to the next slide. Thank you.
Let's see. Sorry, classes, we're trying to get it queued up here. I think it's just a little delayed for Arunima and McMurdo seeing our slide switch over. We're trying to get the tech working as well as we possibly can. Danielle, you're doing great.
Do you have volume on the slide?
It won't necessarily play. If you want to talk over it, that would be great. So, Arunima, if you want to just tell us what's going on in this, because the audio is not working, there's no way to get that working.
Sure.
Yeah, thanks.
Sure. So basically, space weather, the main responsible entity for space weather is our sun. And what it does is sun has a very dynamic magnetic field because of which it's always changing. And actually, the magnetic field flips itself every 11 years. And because it's such a dynamic magnetic field, what it does is it creates these sunspots and a variable magnetic field going out, and because of which we see changes in the space weather, or basically you see more high energetic particles coming through, and coronal mass ejections, and solar flares and things like that coming out of the sun, which is what is responsible for space weather. So right here, if you see these rings, I'm not sure if I am seeing them or you guys have already seen them, but these rings are which are what is responsible for the magnetic field. And when there is a dynamic change in the sun's core due to fusion, these magnetic fields would erupt out, and that is the hot plasma that comes towards the earth, and that's what we experience as space weather basically. And you can see the plasma getting out. So it affects all planets really, but given that we care about Earth more than anything else, it's very important to understand what space weather does to Earth. And as we all know, Earth has its own magnetic field, North Pole and the South Pole. So essentially, this space weather is an interaction between this hot plasma sent out versus our own magnetic field and how well it shields us, or in some cases, if it's too strong of a plasma, how well it does not shield us. So when this hot plasma reaches the Earth, it interacts with our magnetic field basically, and this interaction causes auroras, geomagnetic storms, and various things in the atmosphere. So the auroras is basically a product of a plasma sheet or high energetic particles coming to Earth.
And Arunima, it sort of funnels to the auroras because that's where the magnetic lines come out of the planet?
Yes.
Very cool.
So the end result would be auroras and further geomagnetic storms. Um, if we could go to the next slide, we can talk more. I'm sorry about the network here; it's really crazy. So yeah, basically the sun sending out its own plasma sets off to give us these beautiful, breathtaking auroras. But there's a lot of physics and chemistry going on behind them. Um, they definitely affect our atmosphere, but they also affect our space station uh, and the astronauts on board, satellites, and etc. It also affects our low Earth atmosphere coming down even to the surface level. And there are times when you see auroras even in Northern America and Alaska and even further down. And that's because the storm has if it's a severe storm, you would see it come all the way down. If you could go to the next slide, please. Yeah. So these, it's very important to understand what is happening and how it's happening, because these will affect all our instruments on pretty much all satellites, and every satellite orbiting the Earth would need to be accommodated in terms of drag with space weather. So with space weather changing, it would affect the satellite drag, and different instruments on board cause different types of radiation. And so all our instruments on board these satellites and our solar panels have to be equipped with enough radiation to understand and also to be able to absorb the damage if need be. Next slide. So in terms of science, what exactly is space weather? So the sun's magnetic poles flip every 11 years, and this cycle is called the solar cycle, and this cycle is basically what is responsible for space weather. And all these things that we see, solar flares, sunspots, they're all they're all because of um, they're all because of the solar cycle. Sorry about that. If you could click on the video, please. If you could click on the video on the upper right corner.
Yeah, it's playing. Just delayed for you for a sec.
Did it work?
It's working. We're gonna get it working. This is half the fun.
So basically, the video shows how the poles really flip, and it's really fascinating because on Earth we pretty much have north here, south here, and it doesn't really change. But on the sun, it goes through a whole dynamic process, and basically the north south pretty much become the opposite every 11 years. And this change is what causes all the disturbances that we see, all auroras, geomagnetic storms, and everything else, pretty much in space. We can move on to the next slide if the video is not coming up. So, why do we really need to study space weather? Well, number one, it's a global issue. Not from it, we all need to work together to get this going. And these are mass scale events. Using all these satellites that we have, we only get like a few days of warning that we know that something is going to happen, and we need to use that warning to processes. For example, if we know that there's a space storm, a solar storm coming up, you would not expect astronauts to be outside of ISS doing a spacewalk. Things like satellite launches have to be monitored with respect to space weather to see whether if there's a storm coming in when the satellite is being launched. In fact, SpaceX lost 40 of their 49 satellites on Feb 3rd because they ignored a space weather warning. And it's something that could have very easily been ignored if had they chosen a different launch date, but because they did not look at it, they lost pretty much 40 of their 49 satellites just because of a storm. And it wasn't a major storm that would have affected the Earth that much, but being in the lower orbit, the drag was too much and it affected the satellites. So it's really important to understand space weather and why exactly are things happening, because if it's a severe storm, it would affect our electronics, power lines, and come down at the ground based level. And if it's not that major, it would still affect planes, your satellites, and even your navigation and communication. So it's really important to study and keep an eye out on what's happening. Next slide, please. Next slide, please. So, what does the McMurdo LiDAR campaign really come into in this picture? So, NASA and several other space agencies have over 20 plus missions that are just studying the sun and the dynamics of the sun, and the space weather coming and interacting with Earth. So, McMurdo being at the edge of the polar auroral cap, we see a lot of years where we have a lot of auroras, and then there are some times when we don't see any auroras. So, that gives us an advantage of understanding what would the observations look like in the presence of aurora and in the absence. So, our LiDARs can detect metal layers, gravity waves, polar mesospheric clouds, and polar stratospheric clouds. Now, polar mesospheric clouds is where I come in, and I've been working with NASA's AIM satellite, which is right here in blue, to understand how these clouds are formed and why they are formed and what causes them to vary so much. And now, what's so interesting about these clouds is that they're the highest clouds on Earth, and two, we predict that they could be a long term indicator of climate change. And if that's the case, we would want to know what else can we do to reduce the impact of climate change and how to study it even further. Polar stratospheric clouds, on the other hand, occur at lower altitudes at around 20 to 40 kilometers, even 45, and they play a key role in ozone depletion. So, understanding their their formation, also would play a major role in understanding the global climate change. And is it human-based impacts, or is it something that the atmosphere is doing on its own, given the space weather? Next slide, please. So basically, what do we know from understanding these clouds so far? So these are the highest clouds. Polar mesospheric clouds are the highest clouds on Earth, and they are formed in on the coldest region. So the mesopause, which is one of the layers of the Earth's atmosphere, becomes really cold during this time. The fascinating part is these clouds form during the summer when the sun is supposed to be on its peak, and you would expect things to be really, really cold, really, really hot. But this region of the Earth becomes really, really cold. Initially, it was thought that the solar cycle plays a major role in formation of these clouds, but more and more so as we have more and more data coming in the last decade, we've understood that it's actually the polar vortex that is causing these clouds to form, and solar cycle is playing a minor role, whereas it affects these clouds but not that much. um, Polar vortex is a high pressure zone with cold air, and it breaks almost every year. It has to break every year for the cycle for the global circulation to stay the way it is. And with each time it breaks, we see a change in the upper atmosphere. So what really happens is that the breaking of the polar vortex triggers the season change in the upper atmosphere. So from being winter, it changes to summer. And with the onset of summer season, the polar vortex pushes cold winds basically up the upper atmosphere, and we get extremely cold temperatures in these 80 to 85 kilometers of altitude where we see these clouds form. So it's to understand in the big sense, it's not just a small picture, but putting in puzzles of pieces of puzzles together, wherein we are trying to get the polar vortex, the solar cycle, space weather attached to these clouds, and to see what exactly is happening on ground based levels. And these clouds are really important for us to understand because, as I said, we see that the upper atmosphere is cooling because of these climate clouds. We see the formation of these clouds go higher and higher, and we think that it's because of climate change. But again, you need several years of data to solidify that study. And again, it could be because of human activities, it could be because of the atmosphere doing its thing. But like I said, even rocket launches can cause these clouds to be more in number. So my PhD basically involves in understanding what's going on with these clouds, and how can we understand if it's climate change that is causing these clouds, or is it sun doing its thing and the polar vortex doing its thing. So that's something I've been studying. um, I think that's pretty much it. Next slide. Yeah, so I can take questions now.
Marvelous. Well, thank you so much for that, and for making that work too, Daniela. I know it's always tricky trying to share slides that someone else is talking over, but we're going to dive in with questions, folks. I know we're a little bit delayed with McMurdo, so we're going to try our best to make this as seamless as humanly possible, so fingers crossed to us all. And what I'm going to do is start with a question of my own, give you guys a second to get your sort of thinking caps on and think of some questions for Arunima. My question is, you talked about several days warning if a big solar storm were coming. So we had this dramatic illustration of the sun sending these particles our way and potentially frying satellites, doing all sorts of other stuff. Why do we get several days warning? Does it take that long for the particles to get to us, or how does that work in practice?
Sorry, could you repeat the question or maybe put it in the chat?
Yeah, I can try and put it up on a banner for everybody. So let's see. Long story short, I guess, how long does space weather take to
How
reach
long
us?
does space weather take to reach us? It it depends. It depends on the severity of the storm. It could take from 10 minutes to 3 days, depending on how severe or how energetic these particles are and at what velocity they're going at. But yeah, normally, usually, it takes around 2 to 3 days.
Okay, perfect. So what we're going to do,
And
folks, is
we have
class.
satellites all around in the way, so we can know that they're
Oh, yeah, you're good. Folks, what we're going to do is I'm going to have all our live classes, both on YouTube and StreamYard, because we've got such a significant delay. Share your questions in the chat. I'm going to say a huge thank you and welcome to you guys. We've got Miss Thrasher's class, Miss Henderson, Miss Becker, Madam Christie, our Explorers Club with Miss Snyder, Miss Allen, and Madam Jen's class live with us. We've got a whole bunch of other classes on YouTube, but I want to make sure that we don't have like a minute delay every time we do a question. So share those questions in the chat. When you share them, I'll bring you in to say a quick hello, and then we'll be able to take them so much faster for this Q&A over the next little bit. So I'll share a quick question right now again on screen for us. Let's see. The sun's poles switch instantly or over a longer period of time?
So the poles switch. It's a slow process. The poles switching. It's a slow process that takes over 11 years. And let's say at the start of 11 years, the North Pole and the South Pole are here. It would go all the way up and down, and then you would have them inverted pretty much in a cycle of 11 years. So it doesn't happen instantly, but over 11 years, give or take.
Perfect. Madam Jen's class wants to know.
Have you seen something? So we do have satellites that come close to it, and I think the Parker Solar Probe is the closest satellite that will be to the sun.
Perfect. All right. You guys are so fast with these. I love these questions. Miss Snyder's group, let's get their question in. I want to put it in our banner. There we go. This is exciting for me, folks.
Yes, so you can see these polar mesospheric clouds from Earth. If you're at high latitudes, let's say you are somewhere in Sweden, you could see them with your eyes, because these are night shining clouds. So they glow really well in the night sky. So you can pretty much see them. You don't see them down in Antarctica because we have sun during that time. So it's daylight and it's hard to see these clouds. But up in the northern hemisphere, you can definitely see them. And satellites too can see them. So LiDAR, satellites, and your eyes.
Perfect. Madam Christie's class wants to know. Thanks, Madam Christie's class.
All right. So how do lasers measure the weather? We basically measure temperature and wind, and it's an instantaneous measurement that keeps on going on. So, like, we've been measuring temperature and wind for the last 10 years. And using these measurements, when we plot them out, we pretty much see how the temperature and the wind is changing. So we get to know how exactly is it affecting the weather, or how is the weather changing, pretty much. But the only disadvantage of having a lidar is that we see just one point in the sky, so we can tell you the weather of McMurdo. But if you ask us to tell you about the South Pole, we would need to put a lidar up there at South Pole to measure those.
Okay, fantastic. This is working so well, so much better than I thought it might. This is great. Miss Becker's class wants to know, how do you get interested in the field? Welcome in San Diego.
How did I get interested in this field? I got interested in this field because, well, I love space and I always wanted to study what's happening out there. And I find lasers absolutely fascinating because there's so much of physics, quantum, and electronics involved in it. And that's something that I love to do. So, pretty much, lasers got me into this.
Lasers are pretty cool. We get to have lasers at the Antarctica. It's a very exciting sort of cutting edge science and a really unique place. It's been such a fun part of the series. Let's that's the last question. Miss Thrasher's class wants to know, are the northern lights hot? What an interesting question. I love
Are the northern lights hot? Um, yes, because these are basically high energy electrons charging up your oxygen and nitrogen, and then your oxygen and nitrogen coming down from excited state to its normal state, releasing these fluorescents. So, yes, I would say they are. They would be, at least at that altitude.
perfect. And then Miss Henderson's class wanted to know this.
So, why does space weather affect the satellites? You could think of it as high radiation coming along in the way of these satellites, and the environment around these satellites, the atmosphere around these satellites being changed dynamically because of the space weather. Let's say there's a storm coming in, the storm would cause high radiation and would change the atmospheric drag. And atmospheric drag is something which is really important for a satellite because it basically, think of it as a wind blowing a kite. If the wind is too much, your kite would go either way, right? So atmospheric drag pretty much does that to a satellite. So, like, the SpaceX failure was because the storm that happened affected these atmospheric drag so much that these satellites couldn't take it, and they had to come down to Earth, pretty much burn in the atmosphere, what it was.
Fantastic. I'm going to share a quick YouTube question from Miss
So
Bowers'
do
class.
not ignore space weather is the thing.
Yeah. Let's bring up our question from our YouTube group, Miss Bowers' class. How are you able to survive in the cold down there? It's just too freezing all the time.
Oh yes, I'm able to survive the cold down here. It was a little too much in the starting when we came during windfly, but now it's pretty much warm, so it's not that bad.
Fantastic. I'm going to just take a quick break, Arunima, just to say a huge hello to our classes. Usually we like to have the chance to feature them on camera. So ever so briefly, Miss Thrasher, Miss Henderson, Miss Becker, Madam Christie, our Explorer Club crew, Miss Allen. I just want to say hi to everybody. Welcome in. So nice to have so many classes. Explorer Club, by the way, the girl at the head of the table, you're the best dancer I've ever seen for our warm-up music. So you are awesome. Way to go. You guys all rock. And these questions are great. You guys have been so good about putting questions in the chat. I just appreciate it so much. So just want to give you guys all a quick shout out on camera. Thank you all. You guys have been amazing. And we're going to start sharing a few more questions over the next few minutes. We're doing really well with this question and answer period, actually. I'm very impressive. Miss Alexander's class on YouTube wanted to know, what height do the Northern Lights begin?
What height do northern lights begin? So they could go from around 100 kilometers to 200, even 300.
You're so fast that I'm having trouble bringing up the next questions. This is a good problem to have. Give me a quick second to get these in a banner, and we'll be good from there. Let's see. Madam Jen's class had a good question. There's so many questions. You guys are like so on the ball. I love it. Okay, let's bring this guy up. Oh, that's not it. Sorry. We're going to edit that. It's exciting. I have like the quickest. I'm like typing faster than I've ever typed in history in a program. There we go.
So that's a very interesting question. So rain, so these satellites are basically above 100 kilometers. So we really don't see any rain or lightning up there. But yes, if it did come down, it would definitely ruin the satellites because the electronics, they are solar proof. I mean, radiation proof. I don't know they're waterproof that much.
All right, let's take one from Miss Becker's class. I apologize if I haven't been taking someone's. It's not intentional. I'm just really frantically running through these. But Miss Becker's class wanted to know this, and I'll share another one in a sec.
So how much radiation was there when SpaceX lost their satellites? It was not that high. It was a pretty nominal storm. It wasn't that severe of a storm that we needed special warnings for it. If they had just checked, they would have known. So not that much.
I'm going to bring in Daniela for one really quick too, because we've got a question from Miss Snyder's class around how these sessions come together. So they want to know, how do we organize this to make these work? Thank you so much. This is our first live from McMurdo series. So how does this come to be?
Yeah, so thanks. That's a great question. We are coordinating from CU Boulder with Jesse, who is in Canada, and Arunima, who's down in Antarctica. So we have people all over the world using different types of technology to make this happen. Arunima has been working with us for a year, learning how to engage with students and talk to people and working on her webinar. And we did a bunch of field trips last year. So there's a lot of pieces. There's an IT team here in Boulder and an IT team down in Antarctica that are working with us to coordinate the computers and the bandwidth and all of those things. So it's 7 a.m. where Arunima is right now. She's actually ending her day.
Wow.
She picked up the laptop that didn't work to connect with us. And
That is quite the team effort. Well, thank you, Daniela and Arunima. We really appreciate you being here as you wrap up your day at 7 in the morning. If I have to wake up at 7 in the morning, I'm grumpy. So we appreciate this more than you know. We're going to take a few more questions here, folks. Miss Allen's class wants to know, is the Big Bang space weather or not? Good question.
Is the Big Bang space weather? I think Big Bang would be what formed the space weather eventually because it formed the sun. So technically, yes. But that would be a reach, though.
Yes, it's not in the immediate thing. The Big Bang is the origin of the universe, and it's quite a different. There are quite different scientists that would study the Big Bang versus Arunima and space weather. But I love the thought process behind the question, guys. Miss Henderson wants to know, what's the most severe storm we've had?
Oh, so what was the most severe storms? One of the severe storms basically knocked out power lines and caused blackouts in Northern America. And I think that was one of the most severe storms that we've ever had.
Yes, I'm trying to bring up the name of this so that everyone can see it when I can type properly. There we go. So I encourage our classes to look up the 1859 Carrington event. So this is the biggest
Carrington event. That's right.
Yeah. So this is in a time when we had horses and buggies and there was very little technology in the world, and the solar storm was so powerful it caused like telegraph operators to have sparks come out of their machines. We had auroras on a global scale, so people in like the equator could see the aurora, and in northern latitudes it was so bright that people thought it was daylight. Like they woke up in the night thinking that the sun would come out. That's how powerful the aurora was. So my favorite stat about this, we estimate if a storm that was this powerful today happened, it would cost the world's economy like 20% of the economy. Like it would wipe out all tech, a lot of tech all over the world, satellites, GPS, all sorts of stuff. So we're really hoping that that doesn't happen again. But the Carrington event, I encourage you to check that out, everybody. Let's see if we have any other good questions. I'm going to head to YouTube really quick. Oh, Miss Dupuy's class, welcome in. There you go.
Possibly 21, 22. That's when I understood them really. But I always was into STEM
Yep.
since I was like 10 years old, maybe.
It's I like the fact that you mentioned 21, 22. I think a lot of scientists come on, or a lot of students expect that people know exactly what they want to do when they're really, really young. And increasingly in these broadcasts, we've had the chance to hear from scientists who start quite late. Maybe they go to university, or 21, 22, you're in late undergraduate, where you come upon an idea or a topic that really speaks to you and inspires you. And I think that that's a testament to the fact that you should really have a broad education and learn and check out and see what's out there before you pick a whole career path. And even if you do something that you don't like necessarily, you can start fresh and start again, and you still end up in a position where you're really young and you get to have an incredible job that really fulfills you. So I think that's an important note, especially for our high schoolers today that might be thinking about their careers in the future, is that you can pick and choose and be selective with what you want to do with your career in your life. So thank you for that, Arunima. We're going to wrap up in a quick second. I'm going to see if I can find one more question online. Let's see. Miss Becker's class had this one. Let's put this up on the screen, and then I'm going to share one final question before we wrap up together. Thank you guys so much for being involved today. Question from Miss Becker's group.
What is the cycle called when the sun flips? It's called the solar cycle,
Awesome.
and it's an 11-year-long cycle.
Yeah, perfect. Let's
It's not the sun that flips, by the way, guys. It's the magnetic field, though. It's the magnetic field of the sun that flips, not the sun.
right.
That would be fascinating, though.
Good to clarify that. What's one thing you'd like to leave our classes with? I'm going to put this question up, and then we'll wrap up and say bye to absolutely everyone. So stay tuned, everyone. I know people are going for lunch, but what's one thing you'd like to leave our classes with?
One thing that you'd like to leave our classes with? Well, I would say we need a lot of guys in STEM. So please, everybody, do take up STEM because we need people to come and study the atmosphere, the space. It's too vast for the amount of people we have right now, I would say. We need more
Going to
members on
STEM
board.
is sort of our mandate here at Exploring by the Seat of Your Pants. So I'm glad that that's our takeaway message. Daniela, I'm going to bring you in as well, just to say a huge thank you to you for coordinating this incredible series. Again, everyone can check this out. This is gonna cover up your face for a second, I think, but we're gonna bring it up anyway. Live from McMurdo Station playlist, 4 incredible programs: Ian, Jackson, Yingfei, and Arunima today. It's been such a pleasure having these incredible stories from Antarctica. So I really encourage our classes to check them out. And I will email all our groups with the outreach page or series as well if you want to learn more about the amazing work they do to share Antarctica with the public. It's just been such a fun series of broadcasts. We can't wait to have them back in the future. Again, we'll have to bug Danielle and make that happen. But what we do to wrap up every broadcast, Aruna, but to wrap up your day as well at 7-something in the morning. Miss Henderson, Miss Becker, Madam Christie, Explorers Club, Madam Jen, if you guys want to join me in saying a big thank you and farewell, you are all in the broadcast. Thank you so much, everybody, for your patience, for handling the tech. Have a wonderful day, guys, and we'll see you all so soon.